Hello guys, how are you? Am I audible or not? Okay, so I think I am audible. So today is the first day that I am starting the deep learning problems. So here I am going to demonstrate today transformer architecture, which is the basically the best architecture we can say in NLP, natural language processing, to understand this. So let's go to deep dive inside this. So basically, where is the program inside the code? Deep learning. Yes, so sequence to sequence with neural network. Hello. Hello guys, how are you? Am I audible or not? Okay, so I think I am audible. So, okay, so my audio is also coming very fine today. So now let's continue our discussion on this paper. Like in 2017, the researchers have published a research paper called Attention is All We Have to Need. So basically, this paper is the best paper of all the architecture today. We are seeing ChatGPT, BERT, and Gemini. Something. All of these models basically are coming from the base model is attention is all you need. So we are basically in this tutorial we are seeing sequence to sequence learning with neural network. So this paper is basically I think 2015 or 16, which is the previous base model of attention all you need. So like how previously we are doing all of these like machine learning NLP related tasks, and now we have shifted to the other machine learning approach where we have a encoder and a decoder architecture. So now let's see how sequence to sequence work. So sequence in this type of model, there is three types are coming like LSTM, GRU. These types of model are coming inside there. So the LSTM is long short term memory, which is basically also a good model. Basically, there is two types of LSTM model. The first one is LSTM, the second one is bidirectional LSTM model. So in LSTM, basically we have a forget gate and a memory gate. So basically by doing this, we can able to memorize the previous word. So coming to the point why we have to need sequence to sequence learning models, something like that. So suppose we are doing a language translation problem I am good. In English this sentence is I am good. If we convert this sentence into Hindi, मैं ठीक हूँ. So basically this is not a sequence to sequence mapping. Like the suppose we are doing मैं I, yeah, I is mapped to मैं, it is fine. Like I am is basically not referring to bird, fine. Am is not referring to like ठीक, fine is ठीक, but the sequence is not mapping in this translation is correct. So the researchers have think that now we cannot able to do this type of problems by applying these types of machine learning algorithm, but like simple like LSTM and something like that. We have to apply some another algorithm. So where the encoder and decoder are separated. This is the basically the fundamentals of this sequence to sequence. Suppose if we are doing sequence to sequence, then we can't able to do these types of problems where the language translation is there and some other problems are also there exist. So the researchers came to this model. So basically, in that type of model, this is the encoder part ABC, and this is also end of the string. And by coming applying all of these, we will get our W vector. Basically, W vector is the output vector of our input. Basically, we will provide all the input at a single time, like single frame. Like there is a sentence, I am fine. So basically we will apply a embedding on this, and we will get an embedding vector of that. So basically now the question will like arises, like 80 to 90% people will not know the meaning of embedding. What is embedding? They are doing they know the word embedding, but they don't know what is embedding basically really. So basically embedding is a vector, basically a numerical representation of this I am fine. So basically we know that machines or like computers will not understand this NLP related task. So scientists have come to a point where they have converted I am fine into a some numerical vector. Basically this vector is approx a n dimensional vector. Basically now we are using 1024 dimension vector to create the embedding of every vector, like ChatGPT and some models are using that, but other models we can. But can see that in future this may be increased like 1,000 to 10,000 or lakhs also, because embedding is basically a same like I am fine ka meaning same in the math. Basically we can say that I am fine मैं ठीक हूँ in Hindi and in math embedding. If embedding is basically a very big length where numbers are coming like 0 point something like that minus 0 point something like that. The length is basically very high. You can't able to read this much. So we will apply embedding on this I am fine, and then we will get an embedding vector, and then embedding vector we will pass to this model. After applying all of this thing in encoder, and then will get an embedding vector, we will apply a embedding vector to this model, and then we will get our next word basically. So now suppose we will apply I am fine as an embedding vector to this encoder, and encoder will predict a first word like suppose may. Then we will apply all of this embedding, I am fine embedding and may. We will append embeddings of may into this sentence, and then we will apply the again to this word given to the encoder, and then we not encoded, then we will apply all of this I am fine and append this may in the this embedding, and then we will pass to this again decoder, and decoder will now predict this second word. So now the second word is theek. Now we will apply this word like embedding, and then append to this theek into the previous embedding, and then I given to this again model to in decoder model, and now decoder model will predict like I am fine मैं ठीक, then what will be the possibility of the third word. Basically we at the time of training we will given all of this, like if this is this I am fine, then मैं ठीक, then you have to predict the है. We will train like this at the time of training. So now this model will work fine. Researchers will think about in this direction at the time. So this is the best model. We can say that Now suppose what the problems why they are basically doing all of this thing. Like suppose in the traditional machine learning algorithm like RNN. RNN has lot of problems like this model can't remember the context of the previous bird. Like suppose somebody says bull is going, then you can't you think that there's an animal is going, but if I would say bull is going high, then you will think, oh, this man is talking about the finance. Oh, okay, okay. So the bird, we have to remember the context of the previous bird. Then we can able to know that this man is talking about this context or other this one context. So this is the meaning. That's why we have to come any model then with that which will able to predict like this. So the researchers will came to the attention all is you need. So this is the base model and everyone is now like in 2007 to 2023 like 6 years they all are you doing the same model like encoder and decoder and applying all of this given to the encoder like attention model and then basically they are changing some parameter but not doing any other things basically or they are applying all of this to attention model. So basically this will have to basically this is the best basic model and fundamental model and everybody is using this model so you have to know this. So basically this is the bit of the current time frame and this is the bit of the previous time frame. So and we apply a signum function on that and then we will get a h of t and then again for the predicted word we will apply this h of t into bit of this current node. So this is the all of the function. So by this we are will able to know the remember the context of the previous word. And this is the basically naive Bayes formula to know the next word, which is the possible of the next word. Like now experiment is coming, data set details is there, like which data set they have trained 304 million English words they have selected and train and decoding and the scoring. This is the log function, something like that. Reversing the source sentence and okay. So this is the findings. We can say the result of this model. By applying a single forward LSTM with beam size of 12, we will get a 26.17% of accuracy. This is quite good because NLP is very vast subject, like very big, and at the 2015 or 16, 26% accuracy is good, maybe. And by applying ensemble of 5 reverse LSTM and beam size of 1 we will get a 30%, 33%. And by applying ensemble of 5 reverse LSTM and beam size of 12 we will get a 34% accuracy. At this time this is the best accuracy of this model. So this is the findings of that model and basically Belu means bilingual. So I don't remember bilingual English, yeah, bilingual estimation, something like that. So this is the parameter that we have to know to calculate the accuracy of this NLP related task. So that's it for today. Basically, we are learning sequence to sequence neural network. Now, in the second lecture, we will learn the attention is all you need. This is the paper. Attention is all you need. This paper is basically very good, and here we have learned some mathematics like key, what is key, query, and values. Basically, this has the some mathematical problem also. So we will see that. Basically, today I am demonstrating simple things like why we have to need attention is all you need transformer and all of these things. So this question I will explain in simple word like why we have to need the transformer model. So basically, I already said that in the previous model we can't able to memorize the context of the previous word. So for to resolve this problem, the scientist will introduce a tension is all you need paper, and this is the best paper that they have released, and that's it because of this one only. There's three four types of sequence to sequence model we will also teach in the other section. So thank you guys, that's it for today. Like it, subscribe it, please guys, increase my subscribers as soon as possible as you can. I know my English is not good because I am from village background or something like that. So basically, this there are some problems is also there, but I am trying to increase my communication English as much as possible. But guys, I know everything, but I can't explain in a good manner. I know these things are happening now, but I will improve myself. Please guys, subscribe my channel. Thank you guys.